My name is Randy Becker. I'm with Keysight Technologies, and I'm the director for our 5G testbed program. What I'd like to do is give you a quick overview of some of the things we're showing here at European Microwave in October 2017. What we're showing is some of our latest signal generators and signal analyzers based on our modular PXI form factor. This has a couple of unique advantages and benefits. So inside the platform, you can see there are a number of different modules here. We have PXI modules that perform different functions like up converters, baseband generators, local oscillators. These taken together can form a signal generator, and conversely, on this side we formed a signal analyzer. We could actually combine both of these into a single chassis as well. So this offers a number of important benefits. First of all, it's very scalable. We offer these modules with a wide range of options and performance. It's also very flexible. As I mentioned, you can have multiple instruments in a single chassis that can do different things. Maybe you want multiple signal generators, or even an analyzer and a generator, or multiple analyzers. Additionally, as you can see, it'd be very easy to replace one of these modules. This makes it also very upgradable. Keysight will continue to invest in the latest technologies and will introduce new modules with the latest performance. So what we're specifically showing here is the signal generator. This is the soft front panel for the signal generator. We've tuned the frequency to 28 gigahertz, which is an area that is very important for 5G at the moment. We've set the amplitude to -3 dBm, and we've picked a waveform. It's actually the Verizon pre-5G waveform, which is composed of 8 component carriers. Each component carrier is 100 megahertz wide for a total bandwidth of about 800 megahertz. This configuration can generate signals up to 44 gigahertz with a gigahertz of bandwidth and 1% EVM. For the demo, our device under test is a 4x4 phased array antenna that we've mounted on a platform that can be mechanically steered. We can also electronically steer the beam pattern from the phased array. We can control both the amplitude and phase to the individual elements to form the beam. On this side, we have the analyzer. We're receiving the signal with this horn antenna, and that is then connected directly to the input of the analyzer. And there we're able to make a number of different important measurements. So on the screen, you can see here, first of all, in the middle, we have the 8 different component carriers. We have a pair of band power markers showing the total power. And on top of that, I've superimposed this curve, which is the CCDF curve. So that'll give us an indication of the peak to average ratio for the signal. Above that, we can see the Constellation Diagram, so you can see that this is in fact a 64 QAM signal. Down below here, I'm showing the EVM as a function of subcarrier, but we could also look at that as a function of symbol, where each line here represents each individual symbol. Each symbol, we're plotting all of the different subcarriers. Over here, we see the EVM Metrics. So right now, we're reading about 2.4 over this live over-the-air link. And here we have EVM broken down by the individual channels, like the control channel and the physical shared downlink channel. These two plots are showing the antenna characteristics, and I'll give you a quick demonstration of that. We actually have a small control program here that we're using to control this board, which controls the servo motors and the beam pattern. So what I'm going to do is do a very fast sweep. I'm going to do a sweep from -45 degrees to +45 degrees in azimuth in 5-degree steps. We can set the step size, but I'm going to use 5 so that this will run fairly quickly. So I press run sweep. You'll see that the servo moves, and now we're going to make measurements every 5 degrees. And you'll see the display is updating, so you can see that as we're pointed off axis, that the constellation gets a bit fuzzier because we're receiving little of that signal at that moment in time, and then it should become more in focus and then become fuzzier again as we move away from the receive antenna. So after the sweep is complete, we have a picture here of the antenna power, or the antenna pattern rather, and it looks fairly coarse because I did coarse steps in azimuth. Below that, we're plotting the EVM as a function of the azimuth angle. So obviously we want to know what the antenna characteristics are, but the question that comes to mind now is, how do the RF parametrics change as a function of the antenna position or as a function of the beam angle? And so here we can see that roughly we have areas of low EVM where the power was higher. Here we see a spike in the EVM where we had nulls in the antenna pattern. These two traces here, I'll just rescale these. These are three-dimensional plots. Here I just did a scan at one elevation angle, but we can also scan elevation and azimuth together to form a three-dimensional plot. These are measurements that I made previously, and here you can see clearly the main lobe with the different side lobes, and you have an idea of what the antenna characteristics look like. Below that, we're also plotting the EVM, so the cooler temperatures represent areas of lower EVM. And then this trace on top, I've plotted three different things simultaneously. We have the equalizer response, both in amplitude and phase. So that'll give us an idea of what's happening in the, or over the channel rather. And then this middle trace is showing the equalizer impulse response. And that can also give us an idea of how many reflections may be occurring at any given time. So in conclusion, what we're looking at here is Keysight's latest test bed for 5G and a number of the different measurements that we can make. This is just a sampling of some of the measurements. These screens are completely configurable. In fact, here, if I want to get a close-up of the Constellation diagram, I can do that. And if I put my hand here over the antenna, you can see that the signal will go away. So in fact, this is in real time over the air. So please visit keysight.com for more questions or contact one of your local representatives. Thanks for watching.